sister had tickets for Greek Fest.
All right, good afternoon, and thank you for sticking around this late in the day. It's been a lot of talks. So, I'm Jon Williams. I'm going to talk about the design and implementation of an electronic dice device and some work that I did on randomness during the process of coming up with this. So, who am I? I've been working in the InfoSec world for about 2 decades. During that time, I've spent a lot of time doing your classical castle defense, man the firewalls, watch the IDS, run the proxies, we trust everybody inside, don't trust anybody outside. The last few years, I've gotten into some more interesting spaces. I spent 2 or 3 years doing embedded security, product side security. The last 4 years, I've been working on security for systems running at AWS. And I have been the planning chair for the Children of the CornCon event all 4 years that we've had it. So why eDice? I was looking at getting back into Dungeons and Dragons, and I was looking to get a dice set because I'd lost mine. And when I looked around, the cheap dice weren't cool enough. They were basically really boring, transparent dice, but you can get them for like $6 or $7 in Amazon. The cool-looking dice were not random enough. The swirled dice, the sandstone dice, they have internal density inconsistencies, and so they tend to prefer some numbers over others. They do make cool random dice. You can get machined tungsten dice that have tolerances on them. The problem is those are like $20 a die. And so they're cool, they're random, but they're not cheap enough for me. And then on top of that, I wanted to do a project that would help me learn about electronics, because I'd never done anything like this before. So, in true enterprise fashion, my first decision was build versus buy. So I went out, checked around, and yes, somebody does make an electronic die. That. You can do a die 6. Comes as a kit. They don't do any of the other of the big 7. So, obviously, and thankfully, pushed me into the build space. My initial goals for this project, I wanted to replace the big 7, which are 4 sides, 8, 10, 12, 20, and the percentile dice with an electronic device. I wanted it to be more random than the analog dice. I wanted to have as close to fair dice as I could get. The end product, I wanted to be price competitive with relatively decent dice. So I was looking at something that was maybe in the $10 to $15 range. And I've had bad luck with rechargeables. I've found that I tend to get a rechargeable battery and it will sit in the drawer, and the next time I want to use it, the battery's dead. And it won't recharge because it's the cell has failed. So my goal, I wanted it to run it off of no more than 2 AA batteries. And the 2 AA batteries were because of form factor. And then initially, I wanted to trigger the roll by taking the device and shaking it, like you're rolling your dice. Obviously, since I was concerned with the randomness, I spent a fair amount of time trying to analyze and determine of the methods that were available to me on the platform of choice. My dev board is an Arduino. I started on an Uno, and moved to an Nano for the current prototype. The first one here is using the Arduino built-in random function with no seed. And there's actually sort of a data problem in this. Since you're using no seed, normally you would get the same output on multiple runs, but I was running all of these test cases in a single boot of the Arduino, and when you run the test twice with no seed, it starts in a different place. So it should be appearing here as a single line, and I did another test of it with just that one code, and then I'd run it, collect the data, reset, run it again, and it does come out as same values. The values being shown here are distributions of frequency. So I was testing from 0 to 31, and for each run I did 5,000 samples. Test number 2 is exactly what you would have gotten had I done my test a little differently on test 1. This is using the Arduino internal random function with a static seed. I used 42 as a seed value. And as you would expect, when you use the same seed on a pseudo-random number generator, you get identical output in multiple runs. The third method that I used was to seed the random function with a somewhat random input. And in this particular case, the somewhat random input that they usually talk about on Arduino is to read from a floating analog pin. And when you do that, you get thermal interference, RF interference, and the value you get is not static. So I did that, and I got randomness, as one would expect. Test number 4, I had done a bunch of searching, and I found a guy who had written a randomness library that doesn't use the Arduino one. And it was designed with an eye towards cryptographically sound randomness. And it does a great job of producing randomness, but in tests 1, 2, and 3, I generated 5,000 random numbers in less than 10 seconds per run. Test number 4, a run takes 40 minutes. So there's a significant performance hit when you go for high quality randomness on an 8-bit micro. Test number 5 was an attempt by me, in all hubris, to come up with my own random number generator on an Arduino. Instead of generating it through a program, I decided to try and leverage that randomness from a floating analog pin in order to try and increase the capability of catching randomness. I attached a 6-inch lead to that pin, but left the other end of it floating, so it would act kind of as an antenna. And then I read from it 7 times, I've forgotten. I ended up trying to get a number in the range is what I was running of everything else. First couple of times through, I was getting really weird output, and it was strongly biased. Now I remember, I was generating 7-bit numbers, so I was doing 7 reads from the analog pin, and it was very strongly biased towards 128 or 127, the top number on the scale. That had, out of 5,000 samples, 3,000 of them were that value. Plainly, that was not random. And I went through and I looked and I thought about it. For a while, I thought that it was because of the positioning that I had in the Arduino and the little antenna lead on it, and that it was touching something, and so it was getting a more constant source of interference than what it would normally. What I ended up finding was that I was reading from the floating pin 7 times, and I was only using the top 5 significant digits. And so it was very strongly biased towards the high end. And as any good experiment should, I have a control. I did 2 runs of 5,000 samples from random.org. And they do not use programmatic methods to get their numbers. They have high sensitivity microphones that they listen to, and the fluctuations in noise levels wherever they have their mics generates true randomness. So my hypothesis going into this was that true random number generation, you would end up with a flat distribution. Any number is equally likely as any other. And what I found was that's not the case. The signature of the truly random, coming from non-deterministic means, looks very similar to what I get on all of the others. You know, with number 1 and 2. We know number 1 and 2 are bad because they repeat. And number 3 looks very similar to number 4, where number 3 takes 2 seconds to generate 5,000 numbers, and number 4 takes 40 minutes. So at this point, I decided that even though I know number 3, isn't good. It's not cryptographically sound. For my purposes, it's good enough. This is just another way of looking at the numbers, and it comes fairly close to a straight line, but none of them are actually completely straight across, even the random.org values. So with this, I went into my early prototyping stage. The first two iterations were using the Uno. I started off knowing absolutely nothing about electronics, and so I was reading tutorials and whatnot. And I used pull-up resistors on my buttons, which added some leads. It was, technically correct. But then I learned that there are built-in pull-up resistors on the Arduino. And so, second iteration, I was able to clean up the wiring significantly, remove the resistors from the breadboard, and got the form factor down a little bit. Prototype number 3, I moved from the Uno to the Nano, which made it even smaller. But through all 3 of these, I had the output going to the serial monitor on the Arduino console. And so obviously this is not user ready at this point. So the current prototype, V4, adds on an I2C OLED screen. It adds on a board to handle the power while I try to figure out my problems with my batteries. I'm using a boost converter, and the batch of boost converters I've got boost from the 3 volt that I get off of 2 AA batteries in series. One of them boosts up to 7.5 volt. The other one boosts up to like 11.2. I can't get it any lower than that. And my first attempts with it, I misread my multimeter. I thought it was reading 5.55 volts. It was actually 55.5 volts, and I nuked my first OLED screen, which really annoyed me because that's the most expensive component in the whole thing. Let me see if this works. Because this is live, I did a video of it just to make sure that I could show that it was working. The first button selects the number of sides on the dice, and it goes from 4 all the way up to 100 and then resets back to 4. Second button changes the number of dies being thrown, and then the third button generates the randoms. And if you just keep hitting that third button, it'll keep generating whatever the current setting is. So coming out of this, I've updated my goals. I'm probably not going to incorporate the shake to roll feature in the initial release. It adds some complexity to it. I'm not yet comfortable with everything else that I've got in it. And other than the, oh cool, it's kind of like the analog version, I don't know that it really adds so much to outweigh the extra complexity. I'm considering a rechargeable battery simply because if I go with like a 18650, I've forgotten there's a single cell that I can get that's like 3.7 volts. And that might be close enough that I can run the Uno or the Nano and the display without having to do a boost converter. Obviously, when I get to batteries, I'm going to have to consider power management. I need to be able to monitor the status of the battery so that I can do the display of how much power you got left. I have to think about an off switch or a sleep mode. How do you trigger the sleep mode? So there's a whole bunch of coding stuff that's going to have to come in, and potentially some additional circuitry to be able to monitor the battery. And I'm trying to decide, do I continue working with the Nano or do I go with a completely custom PCB? I want to do that because I've never done it before and I think it would be a great thing to do. I worked on it furiously for the last couple of weeks preparing for this, and I could not eliminate the gulf of my ignorance. And so I wasn't able to get a PCB design for today. I've got a schematic that I think is something like what I want to have happen, but I don't know enough about the electronics to know that everything on here is the way it's supposed to be. In particular, in the upper right-hand corner, there's the decoupling capacitors. I don't know if those are needed if I go with the battery pack going into the, is there a laser on this thing? Not that one.
That'll work. There's the laser.
There we go, found the laser. A linear regulator over here with a couple of capacitors on it. I don't know if I need these if I'm doing that. I don't know if I'm going to go with the programming header on it or not. A lot of this is starting to come down to the, am I making one of these for myself? Am I making a handful of these for my friends? Or, since there isn't anything else like this on the market, do I turn this into a product and try to sell it? Obviously, it's a much different prospect if I'm doing just a handful of them. I've got a programmer that I can plug an 18 mega into and load the firmware myself. But if I'm doing a run of 1,000 of those, that's not going to happen. So I need to figure out what I'm going to do there. And if I do just a small number of them, I'm not going to waste my time with the programming header. If I go with the Nano instead of a custom PCB, I'm not going to need the clock chip because there's one built into it, or the crystal for that. I do like the I2C display. It's really easy. It's 4 wires to connect it up. It's really easy to program. On this, there's not a huge amount of space on it, so you can't do a lot of graphics, but you can do graphics on them. And the power consumption is not too bad. And then, again, the user interface. I went back and forth on, do I have up, down, left, right, and a menu system? Do I go with the 2 buttons to control the 2 factors and a third to trigger it? I'm going to have to go through some iterations to decide what I really want to do with that. And that's the formal part of it. Does anybody have any questions?
What language are you using to program this?
Thus far, I've been using the Arduino flavor of C. I haven't gotten particularly exotic. And I've been using, there's a set of Adafruit libraries for the display, and that, I think, is the only external dependency that I've got. The rest of it ended up, once I finally got my head out of my butt, it ended up being fairly straightforward to do.
What was the cost of the current components you have?
The displays were $12 or $13 for 2. The Nano was, I don't know, $1 or $2. You know, and these are Amazon prices. You can get them a lot cheaper if you go to AliExpress. The buttons I had from other projects. The power board I got 3 or 4 of them for like $6. And you know, I ordered them all from Amazon because I decided to do this talk before I'd actually built the prototypes. And so Amazon was much more likely to get it to me than ordering it from China. Ideally, in the end, if I did take this to marketing, I'd have to go with the Chinese distributors for components in order to be able to keep the price competitive with the $10 to $15 die sets. And of course, I have to figure out a better case than breadboard. I did confirm that the prototype is actually working. If you want to come up and generate some randomness. Other than that, thank you for attending.